I got it wrong, and the other question was the
Okay.
best long-term solution.
Right.
I think the key answer says when you put a flange, the speed will be 533, not 500 like what's in the
Good. We'll look at it, but no.
I calculated that and then I got 500 if you increase
Yeah.
the fan by 25%.
Nope. That's why we're going to do it. So you guys, again, we're here to do the ventilation. I want to go through it. The reason we're going to review this again is this is a complex subject. Usually after the test, we have a bunch of questions, whether it's the fan laws, whether it's flanges. We'll try to go through and answer some of these. So this is out there, guys. First of all, if you don't have this reference, or if you ever want to buy a great reference, the Industrial Ventilation Handbook's really good. Occasionally I'll have people, and Dave, you've done this, what would you recommend? I would recommend this Industrial Handbook. I have got some old ones, and I want to show you guys the old ones, if they're still available. I should have grabbed them. I do have them. Beautiful. So, take one. For the guys online, I know they're saying, what is he doing in the closet? I'm just giving them an old one. I've got some copies here they're welcome to look at. So you guys, again, it's an old handbook. Even if you get the older one, this one's a 25th edition, it's just good to have to review. And you guys may even notice in my copy, I even mark things. And I think there's some in yours too. You're welcome to use that as a reference. What this does do, and again, it's not a requirement for the class because you guys probably are not going to have to design ventilation, but it's a big help to just look at this. And then the other thing, if you're in an employer where you want to talk about fan laws, flanges, this is a good reference to go in and look at, okay? So I just wanted you guys to see those. So some of the definitions in here, and I wanted to kind of talk about these, heating, ventilation, air conditioning, replacement, supply air, general ventilation, and then, of course, the LEV. And each of those, as you go down the definitions, I know you read them, but I just want you guys to pick up what's the difference between heating, ventilation, air conditioning, and general ventilation. You guys kind of said it when we were talking about it. What's the difference? What's heating and air conditioning do?
Heats or cools the space.
Keeps you comfortable, doesn't it? What does general ventilation do?
Increase air quality.
Yeah, it basically removes contaminants. So it's occupational versus, let's face it, just living comfortably, okay? So I want you guys to see that, and that's, again, some of the definitions here. And we talked about this. This is kind of the common terms, and you guys learned those. I just want to remind you again, this X is the distance. These terms, this one I can guarantee you, Q will always be cubic centimeters, or what? Meters per second, cubic meters per second. So remember, international, you've got a few there. Area, again, square meters, or you have a square foot. There you go. So you guys have got it. Depends on where you're working. Here's your key to this. You got to be able to work both ways. I don't care if you're working in North America. At some point, you're going to have a plant that's going to send you calculations. If you're in Europe, Asia, wherever you are, you're going to have to work back and forth, okay? So just be aware of that. And again, simple equation, common terms. What are the purposes of the ventilation? Again, just to review, basically the purpose is protect workers. This is what we do. Now, here's your key to this. What's the difference between dilution and capture? And I always say this, if I am generating a fume here and I'm doing dilution, what am I doing to your classmates? That's right, I'm sharing the wealth, aren't I? If I capture it, what happens to your classmates? And nor do you. So when you guys see dilution ventilation, I always remember one thing. Toxics, I don't want to share with people. As a matter of fact, I don't even want to share it with you. I'm going to pull it in. And that's, again, what you'll see on those. The canopy hood, this is my bias, guys. Canopy hoods are used, but I got to tell you, I do not like them. David will tell you stories. We used to have them on the ships. They were nothing but trouble. So, and especially because people would move them over underneath the hood. So I just want you guys to kind of see that. Again, what's the purpose of ventilation? You've got emergency, you've got the enclosed ventilation, and again, this does comply with ANSI standards, OSHA standards. There's some regulatory to that, well, a lot of regulatory. So, here's your steps, guys, and I wanted to share this with you. This is what an IH does when they say, I've got this vapor, how am I going to control it? I'm sharing the secrets of Pandora with you. I don't know, secrets of, what's a good secret? Who has secrets? Anyway.
Family University.
Yeah, Finley University. Hey, there you go, Dave. I'm going to patent that. The secrets of Finley University. How to do a hazard. By the way, guys, this is not just IHs. This is how everybody should do a hazard assessment. What are the airborne contaminants? What do the workers interact? How are they exposed? And you get to decide dilution and local exhaust. Normally, what do you guys think we try to do?
Local exhaust.
Yeah. When would we use dilution? There's 4 conditions.
In an
Low
unmanned area.
toxicity.
Low toxicity, generation is going to be consistent. It's not like a welding where you're high, low. What else?
When the toxin, you have like ventilation, the toxin, and then you.
There you go. When there's not a distance, you're not directly in there. And then the last one, you guys kind of know this, when you've got enough makeup air to use dilution. You've got the space, not a lot of employees around you. So that's your other thing, proximity. General ventilation. So again, natural ventilation. And this is what we use sometimes in warehouses. You guys know this. We're in Northwest Ohio right now. There is constantly a breeze. So when I say natural ventilation, that kind of should tell you, hey, this gives me an idea of what I'm ventilating. That's why a lot of processes, instead of doing them inside, I'll try to move them outside if I've got my choice. Dilution ventilation, here are the principles again. And I just wanted you guys to see, I said the 4, you guys memorized them, that's awesome, that means you're ready. You'll see that over and over again. So, general ventilation. This is actually for a cleaning a printing press. And if you look at that, right there is where the ventilation is being brought in. Now, the important one, or what I consider, both are important. I don't want to minimize. But local exhaust ventilation. What do you guys think? What's a compound, or where would you all see local exhaust ventilation? Where would it be used? Labs? Absolutely. Hoods. Perfect. Where else?
Industry.
And what industry? What particular area of an industry? I told you guys earlier today I was over at Vaughn Industries. They were doing a safety fair. So with that safety fair, they have a fab shop, a fabrication shop. What do you think they do a lot of in there?
Welding.
They've got welding. Think about this. If you ever have a welder, you want something that will go right at the welding area, the point of generation, that will remove those fumes. Why do we worry about welding fumes?
Heavy metals.
Yeah, heavy metals and not the rock bands, right? Heavy metal music? No, okay. Yeah, heavy metals and actually metal fume fever. Going back to your toxicology. See, guys, believe it or not, what you learned in week 2, you get to bring to week 5. I know you're excited about that. Try to contain the excitement. So, here's basically your local exhaust. I tried to give you a good diagram. I know, again, it's a canopy hood. I hate canopy hoods, but it's the best diagram. If you guys ever see, sometimes in the undergraduates, I'll try to draw things on the board. It's embarrassing for everybody. So this time I tried to give you a good diagram of what's going on there. So here's one of the things you're going to see. What is the volumetric rate? Again, Q is equal to V times A. Now, I'm going to ask, if I call this Q1 and this Q2, what can you tell me about Q1 and Q2?
34.
Yes! Does that make any, I mean, I say this to you guys. To me, and trust me, I'm one of those guys, I got to prove it to myself. This just doesn't, why is this not moving slower than this one that's clay? It never made sense. But you guys are better than I am. You probably say, Don, that's ridiculous. We understand it. Just always, I thought bigger space, it'd slow down anyway. So again, here's what you end up doing. So here's the calculation I wanted you guys to see. And if you see this, I tried to do it in meters per second. So the meters per second, 1 meter duct diameter. Now, be careful. I use duct diameter. So how do I have to calculate my area? What's my area equal to?
1/2 pi r squared.
It's interesting because I do it this way, Dave. So if you use, that's how I do it if I'm using diameter. Now, you will see that if you guys do the problems and you look, a lot of you will use areas equal to pi r squared, okay? So here's your bottom line. This is, I joke with you guys, old curmudgeons like me will use that, okay? But just realize it's the same area calculation. And if you look to the side here, I even put it up here because that's what I like to do. And again, why do I like to do it that way, guys? What do you all think?
That's the way they taught you.
That's exactly it. That's what I was taught. Is there anything wrong with using the radius? No. So I just want you guys to, I had a couple of questions from people on that. And again, you got a couple of different examples here. Clear as mud. These are simple, right? You guys got it? By the way, you will be a hero if you understand that simple part of it. Again, capture of the contaminant is basically you measure at the face value. And remember when we walked over to the lab, kind of showed you what the face of it is, how it works. This is a chart that just to me will throw you guys over the edge. So I wanted to show you this one. This is the ACGIH ventilation chart. It's in your books. I mean, it's in the reading, all that. Here's what flips people out. Let's say I have a hood type, a slot hood, 0.2 or less. Now see this flange slot, 0.2 or less. If you look at those two, what are they talking about? Aspect ratio. Width divided by length. So my question is, if it's greater than 0.2, where do you have to go? Ding, ding, ding. Down to number 3 for a plane opening, okay? So the first question when you're given, if they don't tell you what type of ventilation you have, you need to pop over and look just like Stuart told you in his book. You need to find the aspect ratio. That then tells you which equation you need to look at. Make sense? I know you guys saw that. I just wanted to review it again. Again, here's a good example, a plane opening. If you look at it, because let's face it, people do not weld right at the face. Where do they weld? Usually a distance away. And that's what this takes into account. Here are also some recommended capture velocities. Again, this is out of the ventilation manual. I mean, you guys can just kind of look at those and say, hey, that's something that we need to discuss and know. And again, I tried to give you, this shouldn't surprise you. Just out of curiosity, you guys did this, I think, last week. What is 10 meters per second? How many cubic feet or feet per second is, or feet per minute? What do you guys think? Do it. Go ahead. I want you to remember this one.
About 30.
Try again a little bit. Yeah, try it. You're getting close, Dave. You're doing good for in your head. These guys are looking it up. I don't blame you.
Well, it's going to be between 25 and 30 feet per second.
You're going to make that your final answer?
Yeah.
Okay. What is it exactly? So how much is, first of all, how would you do this if you're playing at home and you don't have the internet? 10 meters per second. What is it?
32.
Yeah, 33. I just always remember 33. Don't ask me why. There's your trivia. And Dave, you did good to get 25 to 30. How'd you do that so quick? You just took number of feet in meters?
Yard is about 3 feet.
Good. There you go. You gotta have those cheats, guys. I know this is a cheat, and I'll use it all the time. 10 meters per second. When you're talking to me about it, I instantly kick to 33. Yeah. It's just a cheat, guys. I'm trying to give you hints when you're dealing with different units. It'll kind of help you out.
The meter's about a yard.
About a yard, yeah. So it should go about 3.
Basically a meter's a yard plus 1 inch.
Okay, thank you. Because I do not, and guys, by the way, I'll admit it on video and I'll admit it to you guys, I do not memorize unit analysis. That is something that you don't even have to memorize it on the CIH, okay? So any of your board certifications, you don't have to. So again, the canopy hood, you guys saw one over in the lab. Here's what I really like. Why do I like elephant trunks? What do you guys think I like about these?
You can move them to the source.
Absolutely. I can move them around because there's nothing worse than a worker not being able to move them around. Same thing. This is an interesting one. I'm going to tell you an application here at the university. If you guys do not know, we have a cadaver lab here. In other words, we have bodies after people die, they donate their bodies to medical schools, things like that. So when those bodies come in, they're preserved in formaldehyde. If you guys know anything about formaldehyde, you're going to say, oh, wait a minute, that is really, really bad. So here's your key to that, and I want you guys to know that. These downdraft tables, they lay the bodies on them, and then they pull the contaminants away. It is really a cool thing to see, and if you're ever sampling, it's amazing to watch it. And especially the flow on those are great. So there's your kind of your thing there, your slot ventilation. You had one over in the lab, but I just wanted you guys to see it. And then my favorite one, the hood. Yes, the hood's there also. Here are some enclosures that are local. What do you guys think this enclosure's used for?
Painting.
What type of painting? Absolutely. Parts, things in there that they can go into. Again, the operator wants to be upstream. And then my favorite, the glove boxes and abrasive blasting. So LEV, one of the things you guys have to worry about where the stacks are venting. And I say this only because I was involved in a decision that almost really messed this up. One time we were venting the stack, the ventilation system vented out. What did we forget about? If you're moving, let's say you have a moving object with your stack and you're going forward, so you're going toward it and your intake's behind it, what happens with everything being vented? You're sucking it right back in. Hopefully during the design you capture that. Same thing here, do not put your exhaust stacks too close to the intake. And I know you guys are going to say, we'd never do that, Don. There's no way. Trust me, I almost did it one time. Yeah, absolutely. We were designing a ship and we ran kind of out of space, so it's kind of funny. You guys got to see the barometers. Basically uses air movement, anemometers too. We talked about that again. You can get different readings on them. And sometimes, you know, especially when you're doing determinations, you want to use different types. And I just tell you, there are different types. I personally will only use the electronic ones, but you've got a lot of people that want the swinging vane velometers. You guys will see those used, and the hot wire. So just different types. Now, at the end of the day, what are you guys going to want? Unless you suddenly become an IH, you're going to want to know what is either the total pressure, what is the velocity. With that said, what do I do if a hood's not working? I'm going to share with you the troubleshooting secrets, I'm going to say of Don, not University of Findlay. So again, long hood for the process. You guys know that. If you're trying to use a canopy hood, one of the things, what do you have to do? If the canopy hood's above it, what do you guys have to do? What do the vapors have to do? If they're heavier than air, what's going to happen? Yeah, it's never going to work, is it? You're probably not going to be able to use it. So that's, kind of areas. Insufficient makeup. I installed for a combustible dust. It was a sugar plant. It was designed. We told them how much makeup we knew it would take. They said, we can't afford that extra makeup volume. We're going to cut it out. What do you guys think happened when it started working? It didn't remove the combustible dust. So guess what they did? Go back again, reinstall it. So they had to get the makeup volume. So just common errors. So here's your exercise. I want you guys to read this. What do you guys think? Preferred ventilation system for the following. Delete non-toxic odors in a warehouse.
General ventilation?
Yeah. Why is that? What four conditions we talked about? Not toxic, not a lot of people around. We're assuming in a warehouse, not a lot. So there you go. First question. What about this one? Acid bath with an open surface area.
Canopy hood.
Yeah. Canopy's probably good. Some people would say, hey, I want to put it in a paint booth, but it's not really applicable. So I just wanted you to see that one. What about this one? A welding table. Come on. My favorite one.
Elephant trunk.
There you go, elephant trunk. Thank you. Again, guys, and you can make the argument maybe something in a situation may be better, but I'm just giving you a general out of that. Chemical analysis, small samples for quality control. There you go, level. Yes, thank you. You guys, I get excited. Spray painting, large piece of equipment. Yeah, paint booth. This gets easier as we go along. Guys, here are the standards, and I want you guys to know these are U.S. standards, okay? Some of them are pretty good, and I will tell you, I have used them in non-North American areas, and if you need other standards, especially some of the consensus ASHRAE standards are pretty good. The other thing, ANSI also has standards. So here's kind of what we talked about in it. Again, I just wanted to spend a little bit of time with you guys on ventilation. The other thing that we'll kind of talk through, and I'm going to remind everybody again, please make sure if you have questions about any of the ventilation or any questions after you do it, before you do it, when you're reviewing, come back and ask me those questions. I mean, ask me in an email, ask me during, you guys have the advantage, we can work on them during class, whatever you want to do, or if you want to set some time aside, guys, I'm available, so let me know. What will happen the next couple of weeks, I'm going to bring some practice exams into here, and I'll be sharing them online too, so you can kind of practice some exams to get you used to what's going on there. Any questions on the quick review of ventilation? Good. And if there are problems on it, let me know. I'm going to keep going through now, and let's do.
Show up in Canvas all of our quiz answers.
It doesn't. If it doesn't, that's the other thing, and I'll say this online. If you guys, after you finish a quiz, cannot see the answers, let me know immediately. I thought I had all the sections set. You guys are in a different section, so maybe I missed some of yours.
And I want to say, I'll have to look again, but like one quiz, it starts like halfway through the quiz.
Yeah, it shouldn't, but I'll see what it does. Yeah, let me know.
I mean, I broke